Today's lesson is Lesson 3 in Chapter 15 for Advanced Math, or Chapter 10 in Regular Math, on experimental and theoretical probability. So experimental probability is the probability that is based on repeated trials of an experiment. So this is when you're actually trying something, or when something's actually being tried or experimented to see what will happen. So the probability of the event in experimental probability is the number of times the event occurs over the total number of trials, or the total number of tries that you had. Here, in example 1, what is the experimental probability of rolling an even number? So we would write this out like this. We would say the probability of an even number is equal to the number of times it happened out of the total number. So we're going to use this chart down here. So we know that even numbers are 2, 4, and 6. And we would add these amounts up. So we have 4, 11, and 6. When we add those up, we get 21. And then we have to add up our total. So we know we have 21 plus 10, 8, and 11. So that's 29. And when we add those together, we have 50. So we know that the probability of this is 21 out of 50. Or this would be 42 out of 100, which can be written as 0.42 or 42%. So we can write it as a fraction, as a decimal, or as a percent. So with number 2, at a clothing company, an inspector finds 5 defective pairs of jeans in a shipment of 200. If this trend continues, about how many pairs of jeans would you expect to be defective in a shipment of 5,000? So we have 5 out of 200 are defective. How many, an unknown amount, would be defective out of 5,000? So we can use a proportion, and then those cross products are a butterfly method to solve. So 200 times x, 5 times 5,000, and then use those inverse operations to get the variable by itself. So x would equal 125 defective pairs of jeans. So what we just took a look at was the experimental probability when we're trying something. Here we're going to talk about the theoretical probability. So when all possible outcomes are equally likely, so there's an equal chance of each outcome happening, the theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. So think back to favorable and possible outcomes from lesson 1. So now it says in example 3, what is the theoretical probability of choosing an X? So we see here that there are 7 letters and there is 1 X. So we know that the probability of choosing an X is 1 out of 7 because there's 1 X cube out of 7 total cubes. Number 4, the theoretical probability of spinning an odd number on a spinner is 0.6. The spinner has 10 sections. How many sections have odd numbers? So we know that 0.6 is going to be equal to how many favorable outcomes out of 10 possible outcomes. So we can solve this equation, or this proportion. So 10 times 0.6 is 6, because we're multiplying by 10 on each side. So we know that there are 6 odd numbered sections. Now you go ahead and try number 5 on your own. And one piece of information that I added in your guided notes was that from example 4, the probability of a bobblehead is 1 out of 6. So let's put this in here. Probability of a bobblehead is equal to 1 out of 6. So go ahead and try to complete number 5. So here, if we know that the theoretical probability is 1 out of 6, and we know that the wheel is going to be spun 540 times, we want to know how many times we would win a bobblehead. So 6 times x is 6x, 1 times 540. Use those inverse operations. So we have x is equal to 90. So there would be 90, you'd predict that there would be 90 times that a bobblehead would be won. In number 6, we are going to use the graph that they've given. So it says use the bar graph in example 5 to find the experimental probability of rolling a number greater than 1. Compare the experimental probability to the theoretical probability. So let's find the experimental probability first. So we know that the probability of rolling a number greater than 1 is equal to what? So we are going to add up all the times that rolling a number greater than 1 occurred. So we're going to add 53, 50, 52, 49, and 48. And I believe when you add those numbers, you get 252. Now, the bottom number is the total trials that there were. So we have to add the ones that we didn't originally count into that number. So we know that this is 252 plus 48 is 300. And then we can reduce and simplify from there. So both of these are divisible by 2. And then both divisible by 2 again. And then these are both divisible by 3. So we have 21 out of 25, or this would be 0.84 or 84%. So it's 84% likely that you would roll a number greater than 1 in this experiment. So now let's try the theoretical probability. So with the theoretical probability, remember that the probability of rolling greater than a 1 is the number of favorable outcomes. Well, the favorable outcomes of rolling greater than 1 would be a 2, a 3, a 4, a 5, or a 6. So that's 5 of those favorable outcomes over the possible outcomes. So we know that we have 6 possible outcomes. And then we would need to change this to a decimal and a percent. We can do that by dividing. So 5 divided by 6. When we do this and you work it out, you're going to get 8.3 repeating. So we can say, sorry, not 8.3, 0.83 repeating. So 0.83 repeating, which would be approximately 83.3%. Now, comparing these, we can see that the experimental probability is slightly higher than our theoretical probability because 84 is larger than 83, but they are very close. So we can see that this is reasonable. This experiment was done correctly. It's reasonable information. If these numbers vary greatly, if they are a large difference, we would want to consider if there were errors made in the experiment or if we made some miscalculations. But since they are very similar, we know that we have good information.